Hello everyone. So today we are going to solve FlipMed, which is a machine coding question, which is asked in many companies, like Flipkart is one of the examples. Okay, the problem statement says that we have to build a simple application. It will be an in-memory application for doctor appointments booking, right? In a single day schedule. So what will this application allow? It will allow the doctors and the patients to register. Doctor can declare its available time slots, and the patients can search for the available time slots, and even doctors can view the bookings for himself, right? And the patient can book the appointments and cancel the appointments if a patient wants to join a wait list, right? If the appointment is already booked by another patient, then he can join the wait list also, right? Okay, so if we note down the functional requirements that is asked in this, register a doctor, register a patient, declare doctor's availability, which will be declared by the doctor. The patients can search, and he can book the appointment, he can cancel the appointment, and the bookings can be viewed by the doctor or the patient. Okay, and yeah, mostly yes, and the yeah. So if we see, you can read out through this document for more information if you want. So if we also see, there's an extra requirement which says that the doctor can have a rating, and and the when we are viewing the searching the available slots, it can be ranked by two ways, by rating or by slot start time. Okay, so there's a two type of sorting is available, which can be done by the strategy design pattern. So we can declare a strategy and a class, and we can implement two classes from it. One is the rating based rank strategy, and the other is slot start time strategy. Okay. So coming to the entities for it, if you see, there's a doctor entity because the doctor has to interact, and there is a patient entity, and there is a uh, patient to doctor booking, right? So if we see the entities that we first have the doctor entity, and then we have the patient entity, and then we have the booking entity. So we'll start with the models that we have in this. We'll start with the doctor. School. So doctor will have its ID, it will have its name, right? And it will have its specializations, right? So there's a enum declared for specialization. We can see there are different type of specialization for a doctor. Okay. So let me close all first, close all tabs. Okay, so coming back to doctor, and the doctor can also have a rating, right? So yeah, this is this. So as mentioned, the doctor can declare his availability, like at what time he is available for the day. So we can create a hash map, or you can say concurrent map to avoid the concurrency issues and all, right? So we'll have a availability map, concurrent map, which will have the key as time slot, and will have a flag called boolean, which is available. It will be true or false depending upon the availability of the doctor. Okay, and then we also have a slot lock, right, for a time slot, let's say 9 o'clock. Uh, we can acquire the lock so that concurrency issues don't happen, right? And since we have also declared a constructor, which is a parameterized constructor with the parameters that are required when we are creating a doctor, right? And we have a get method for the lock based on the slot time. Okay, so coming back to the next entity, which is the patient entity, it will have ID and name for this application. Is sufficient for now, and we have a booking entity which will have the ID, doctor ID, patient ID, and the time slot. Same thing, we have the parameterized constructor for it. When we are booking, we will require a doctor ID, patient ID, and the time slot, right? At 9 o'clock or 10 o'clock or 9:30, 10:30, at what time he is trying to book the patient is trying to book the doctor. And we have just two string method which you can use for printing and all, right? We also have three exception class. One is the booking exception class, which extends the runtime exception. Same goes with doctor exception and patient exceptions. So we should have different exceptions class so that we can handle the exceptions in a much better organized way, right? And we have three repositories, each for the entity. One is the doctor repository, patient repository, and the booking repository. So if we come back to the doctor repository, so at any point of time, so these are all in memory uh, map. So we have a doctor map which will have the doctor ID and the doctor entity itself, right? So this is to save all the doctors that have been registered in this application, right? And there are few methods, which is called save method, find by ID, if you want to find a doctor, find by specializations, right? So if you want to save a doctor, you do doctor map dot put. If this doctor UUID is already not present, so it will save the doctor in this in memory map. And if you want to find that doctor by a UUID of the doctor, you can do doctor map dot get, right? And if you want to find by specialization, we do on the doctor, we have a parameter for specialization. We'll find by that parameter. Okay, coming back to the another repository, which is a patient repository. You can save a patient. Same thing will have a concurrent map to avoid the concurrency issues. It's the patient ID and the patient is the object. So we'll save the patient in the map and you will find the patient by the ID if required. In future, we can add more methods if it is required, right? Coming back to the other repository, which is the booking repository. So if you see our yeah, MD file, right? So the booking repositories allow us to book appointment or cancel appointment and view the appointments, right? So we'll have one for booking the appointment, one for canceling the appointment, and one for finding the booking, right? It will be required, and other by finding the bookings by the doctor ID, if the doctor wants to view all the bookings that he has done, right? That is one thing, and same thing goes for the patient, right? The patient can also request to view all these booking. So we can do from the booking map when we have let's come back to the saving of the booking. So we'll have a booking entity pass on to this method, and then booking will in booking map will save the booking where the key is the booking ID and the value is the booking entity, right? So same thing, we can delete from this map, and if you want to find by a booking, we will do booking map dot get ID to get by the booking ID. Coming back to the list of bookings, so from same thing, from booking map we will filter by the doctor ID that is passed to this method, and then we'll get the list of bookings by the doctor ID. And same thing goes with the patient, because booking map has couple of things, right? Doctor ID, patient ID, and time slots, right? In future we can also write a method to fetch the time slots. At this time slot, what all bookings are there, right? That it can be also one way method in this, which is not required in this case, but in future it might be required if you're building on top of it, right? So the other thing is, uh, let's say there is a doctor, right? Doctor called AK, right? And the doctor has a booking at 9 o'clock, right? And booking by patient one, right? And there's another patient who wants to visit the same doctor at the same point of time, right? So we'll allow, there's a feature in this which will allow the patient two to be waitlisted for the doctor one at the same point of time, which is 9 o'clock, right? And if the first patient cancels the his booking, then this patient will become the next book patient for that particular doctor at 9 o'clock, right? So what we'll do is add to waitlist me. We'll have a key like uh, doctor ID and slot start time, and then there's a queue of patients, right? So if you see the waitlist object, so I think we are clear with this booking object, and there is a waitlist object which will say which will have a key called doctor ID and slot start time and the patient queues, right? So you can see the example here. So let's say the doctor ID is 123 and the time is 9:30, so it's like this, and then patient is in the queue. So first P1 will be served, and if P1 has cancelled the booking, then P2 will be served, right? And similarly it goes on. right? So we are using concurrent map here also to avoid the concurrency issues. So the key will be this, and then there's a queue of patients ID, right? A queue of patients which has been waitlisted, correct? Okay. Okay, so coming back to the waitlist function, what we'll do is we'll get the waitlist for that doctor slot time, right? So the example is 1, 2, 3, 9:30. We'll get for 9 o'clock for doctor 1, and if um and get the queue, right? And then what we'll do is we'll add that patient to this queue, right? If the queue is uh, not empty, we'll create this queue and then add the patient to it, right? So if you see, we got the queue, and then if queue does not consist the same patient ID, then that means that the patient is a new patient and we added to the queue, right? If the patient is already exists, we don't do anything, right? We have added a synchronized block to avoid concurrency issues, so that not another patient at the same point of time tries to add his wait list, right? So at a time, only one patient can be served and added into the wait list, which will be on the basis of first come, first serve basis, right? Okay, then coming back to the pop from waitlist, right? When the patient has cancelled the appointment, we have to pop the next patient in the queue, right? So for the same doctor slot for which the appointment was cancelled, what we'll do is we'll get the queues or get the queue patient queue, and then what we'll do is if the queue is returned empty, then we'll return null that there are no patients to be served now. Then the appointment is or the slot is empty, right? And then what we'll do is we'll try to add a new patient to this, right? Sorry, we'll try to fetch a new patient from this. So what we'll do is we'll get the next UUID or the patient ID from the queue, and if next is null, then what we'll do is uh, if the next video ID is queue is empty, try best effort cleanup. Then what we do is we just clean up this queue, right? Waitlist dot remove doctor queue dot. So we remove this null value, and if the queue is empty, then what we'll again do the cleanup part, right? This can be ignored if you want, because mostly everything this are the handling cases or the edge cases handling. So what you can do is you can simply return the next patient ID. So let's ignore, if you ignore these parts, so when you pull the queue, right, for the next patient IDs, you have the next patient ID and that you will return from this, right? And to handle the edge cases and all, if it is null or the queue is empty, what we do is we are simply cleaning up the queue. And if you see, we are returning null. Okay. Okay, this was the doctor repository, booking repository. I think we have seen all the repositories, right? Before we go back to this each of these services, we'll go to the strategy that is required for this question, right? There are two type of strategies that is required: start time rank strategy and rating best rank strategy. So what we'll do is we'll declare an interface called slot rank strategy. So whenever the patient search for the available slots of the doctors, right, for a particular specialization, we return the doctor slot, right? So that that has to be sorted on the basis of these two strategy, or when based on what the application is built on or what the patient has requested, right? In UI there will be filters or something, according to that it will be declared, right? So what you will pass is you will pass the list of doctor slots which are available, and then that will be sorted on the basis of the strategy that is required for this, and then the new doctor slot or the sorted doctor slot will be returned, right? So if we come back to this, we have declared interface for the strategy pattern, and there are two classes which are implementing on top of it. So one, first let's focus on start time rank strategy. So what is happening here is we have the list of doctor slots, right? And then what we'll do is, so start time, on the basis of start time, we have to sort this, right? So 9 o'clock should come before, or 10 o'clock should come before, something like this, right? Before 10:30 or something. So we have the list of slots. What we'll do is we'll sort this out and return that slot. Uh, so in this, we'll be comparing the slot timing. So if you see doctor slot, this is a DTO that has been declared. which says doctor and slots, right? So we see doctor 1 is there with at 10 o'clock, doctor 2 is there at 10:30 and on, right? So it will be sorted on the basis of slot, right? So if we come back to this, we are sorting on the basis of slot. If so, there is a utils method written here to convert the string, because we'll be taking input in string for this purpose, but in on a large scale application will do all the time conversion beforehand and do it, right? Or we can do it here itself. So what we'll do is, so in this utils method, convert string time to slot, we'll get a string time and then we'll sort it out, right? Based on hours or minute, hour, minutes, AM, PM, if it is a return, right? And then return it out. Okay, and we'll have that time slot in the proper format to local time, and then that will be sorted on the basis of start time, right? And then there is a rating based uh, ra ranking. So again, we'll have the same slots, and that slots will sort. So this is a lambda expression with where we have declared Dr. A and Dr. B, and then we are comparing the Dr. B with Dr. A. So what we are doing is we are sorting the doctor which has highest rating than the other. So the highest rating will be on top. So this is a descending order sorting. So this B is first and then A is second, right? So double dot compare. We'll do the rating comparison and the slots will be sorted for this. Okay. I hope I'm clear with the ranking strategy. If you have any questions, please ping in the comments and I'll take it forward from there and maybe post something or post a separate video for any doubts that we have. Okay. Cool. Then I think we have covered all the things that are there. The only part is the service part. So if you see the doctor, for doctor service, what do we require? Doctor has can register and doctor can tell at what time slots they are available, right? So we'll go to doctor service. So what we'll do is we'll pull under the doctor repository and we'll we'll declare the doctor repository with the help of the constructor. And then the doctor can register or he can declare his availability. So these are the two services that are required, right? So for registering a doctor, if you go and see the um constructor, we require name, specialization, and rating, right? And the UUID is randomly generated here, right? So we have declared a new doctor, and then what we'll do is we'll save this doctor into the doctor repository. So it will go in this method and it will put inside this map. In place of this, if we have a database connection, then it will put inside the database. Okay. So the doctor has registered here, and then the doctor will declare his availability at what times they are available. So let's say a particular doctor will come and he will say or she will say that he is available at 9 o'clock, 10 o'clock, 3 o'clock, something like this, right? So then we'll check the doctor repository by this map to check if the doctor is valid or not, and then if the doctor is valid, then we'll go to the next thing and we'll get the time slots for all the time slot that he has passed here. Will get the availability object of the doctor, which is this, because we want to store the time slot and the availability of the doctor. And we'll put this slot and the boolean as true that the doctor is available at these slots, right? And once the slot is booked, we'll make it as false, right? Okay, I think I am clear with doctor service. Coming back to the patient service. Again, the patient can register a patient. The patient service can register a patient, or you can get the details of a patient, right? If you want, right? So not required maybe in this case, but take it. So we'll register a patient. Same thing, we'll declare the patient object, which requires only name and ID is randomly generated here. And then we'll save that patient. So the patient will be saved in the patient map here. So the patient ID and patient. Okay. And then and then we'll return that patient. Same thing, if you want to find by a patient ID, and then we can do this, right? Now, coming back to doctor service, I think we have already seen patient services. Now coming back to booking service. Now there are multiple functional requirements here, right? One is the search. The patient can search the doctor, he can book the appointment, and he can cancel the appointment, correct? And then the doctor can view the appointments or the bookings that he has by the with the help of doctor ID, and the patient can also view the appointments if required, right? So coming back to this service, again we'll need two repositories as of now, which is a booking repository and doctor repository, to interact and get the data. So for the search, right, so the patient will, what it will do is it will search for a specialization, and we will be also passing the strategy that is required here, right? So if you see the strategy that is required here, rank strategy, that is a rating based strategy, or this can be changed into start time strategy also, right? Start time strategy, right? We'll use the rating based strategy as of now. Okay, now coming back to search, so we'll find the doctor, right? By specialization. So they, let's say there are two, three doctors for the same specialization called cardiologist, right? So or yeah. So we'll go to the doctor repository, and there's a method that we have already written for specialization. So it will go inside the doctor map, right, and find all the doctors with the mentioned specialization, right, and it will return as the list of doctors, right? Now what is required, there is a sorting or ranking required here, so right, so we'll rank these doctors on the basis of that, right? So if we go to this method, and then we'll so we'll rank here. So for ranking, I think if you see the object that is required here, doctor and slot DTO. So what we'll do is we'll convert this doctor list to list doctor slot, right? So we'll iterate over this, and then we will create this doctor slot, right? And then we'll rank on the basis of the strategy that is mentioned, correct? No, the other thing is that the patient can come and book. So for booking a appointment, right, patient ID is required, doctor ID is required, and the time slot at which the patient wants to book, correct? So that is also written there. So first we'll check if the doctor is valid or not, right? And then we'll get the available slots for the doctor. So once we find the doctor is valid, we'll get the available slots for the doctor, and then we'll get the slot. The doctor does not declare the slot. Okay. If we get the slot, let's say it is 8 o'clock, and the doctor does not have a slot at 8 o'clock, correct? So then we'll return a method error called booking exception, because these are all related to booking, that the doctor has not declared the availability for 8 o'clock, right? Okay, now let's say 9 o'clock is the slot for which the patient is booking for this particular doctor. So what we'll do is we'll acquire a lock on that particular time slot. So if we see this lock, right? Slot lock. So it has time slot and the lock, right? So string and the lock, right? So it will acquire that lock at that point of time, so that another patient does not book at the same point, right? At the same time, if two patients are trying to book at the same time, then it will have handle that concurrency, and it will not allow the other patient which was little late than the first patient to enter this block, right? So we have acquired a lock on that particular time slot, and then what we'll do is uh, we'll again start the slot state if the slot is available or not, and if the slot is available, then what we'll do is we'll start the booking process. Okay, so let's say what is happening. So check for duplicate patient. Patient already has the same slot. So what we'll do is from the booking repository, we'll get the booking file for that particular patient, right? And if the doctor ID and the time slot matches, then it means that the slot is already booked, and we should not allow the patient to book the slot again, right? So either you can handle this in backend saying that the appointment is booked, or you can throw an error or an exception here that you have already booked this uh, appointment with this doctor at this particular time slot. So this is the duplication check here for the same time slot book, right? If the slot is available, now we have this thing, right? The slot state, right? If the slot is available, reserve it and create a booking, right? So what we'll do is in availability object or the map, right, which is for the particular doctor, right, here. So we have to make it as false, right, because the time slot is not available now once the booking is done. So we make the slot as not available, and then what we'll do is Double check for reservation. Again, these can be avoided if uh, I don't think it's required again and again, but you can do a double check here also. Post check again, get the patient and if this time slot is there or not, right? And then what we will do is we'll create a new booking, right, with the doctor ID, patient ID, and the time slot, right? So if you see doctor ID, patient ID, and time slot. So we have created a booking and we'll save into the repository, which is the booking map here, right? The booking ID and the booking object entity. So the booking has been saved, and you can say that the booking is confirmed for this doctor at this particular time slot and return, right? And then if this slot is not available, right, particularly slot is booked by you, and I'm booking these same time slot for the same doctor, then what is required is that I should be waitlisted for that particular doctor for that particular time slot, right? So there's a method that we have already written. I think we have gone through it also. That is add to waitlist. So the I will be added in that particular queue so that once you cancel the bookings, I will be the next patient uh, that will be served by that particular doctor, right? So if you see, so what we're doing is we have generated a key, which is doctor key and time slot, doctor ID and time slot, and then we have added to this slot not available, patient added to the waitlist. So we can add this. And then finally, once all these things are done, right, the slot booking thing and the waitlisting thing, right, in the final block, we can release this lock, right? Uh, so that another booking can be handled by another patient, right? If we don't release this lock, then this will be uh, locked indefinitely and then the system can crash. Okay. Now the other part is the cancel of the booking, right? Now let's say you want to cancel the booking. So in canceling of booking, what do we have to handle? We have to handle the canceling part of it and then popping out the next patient in the queue and serving that patient, correct? So again, what we'll do is we have the booking ID for which we want to cancel. We confirm if the booking ID is valid or not, and then we'll search the doctor for that. And then again, just verifying if the doctor is valid or not. And then we have the time slot that we can get from the booking object, and then we'll acquire a lock for that particular time slot because we don't want any other patient to work on that time slot at the same point of time or they cancel or something like this, right? Now the lock has been acquired, which is a time slot lock. I think I'll show you again. So if you see, it is a time slot lock. For a particular time slot, there's a lock. So now mark slot as available. So now what we'll do is we'll mark the slot as available. So available put me if you see, what we are doing is doctor slot and value. Doctor slot and value for this particular doctor, for this particular slot we are setting some value, right? So you can directly add this thing also that our doctor is available here. I can show you this part, right? This is also fine. um, okay, so for this particular doctor, this time slot, the slot is empty because you're canceling the appointment at that time slot for this particular doctor, correct? Now what we'll do is we have to also delete the booking from the our in memory or the database. So we'll remove that booking here from here, correct? Remember that the lock has been acquired. Now what we can say, if the booking is cancelled after deleting the booking from the repository, and then what we'll do is we'll fetch the next patient that is in the queue, correct? So we'll get the key, we'll generate the key that this is the key, and then we'll fetch the next patient from the repository. So which is the popping of the next patient ID from the queue, right? We have the next patient ID, and if it is not null, then we will assign that and then finally release that lock. So if the next patient ID is valid, or if there is the next patient ID ideally, so then we'll assign it to that patient. So what we'll do is in booking repository, we'll find that patient first, and we'll see if it already has a um, booking or not, right? If it does not, if it already has a patient booking, then we can say this the next patient already booking, skipping the assignment. Okay, these are for handling extra cases but not required mostly, but you can add as to showcase that you're handling multiple edge cases that are there, right? So this is for ensuring that there is no duplicate booking, right? If there is no duplicate booking means The no now the booking has to be confirmed, right? So what you will do is we'll mark it as false, the slot for the particular doctor, and then you will create a new booking with the doctor ID, patient ID, that we have gotten from the queue, and that for a particular time slot, and then we'll save this booking, and we'll return thus that booking is confirmed for the patient with the doctor at this time slot, right? And then we release this log. Cool. I think this is clear, and to view, I think already we have already taken care of this, right? I hope I'm clear till this. We'll come back to the app method, which will replicate or simulate the working of this, right? So coming back to this main method, so when you run this, let's run this, right? Cool. So, so first of all, right, to simulate this, we'll declare all the repository, or you can say create all the repositories, create all the services, declare the strategy that we want to use. Correct. Now the next step is what are the next steps, right? The next steps are the doctor will come and register, right? And then doctor will declare his availability. So that is what we're doing. So we are declaring two doctors, Alice and AK, and booking their availability around 9, 9:30, 10 for this 11 o'clock or something like this, right? If there are more slots, you can add it here. And for declaration, we need the name, the specialty, and the rating for this particular doctor. Okay. Okay. Now the next thing is the patient will come and register. So what we have done is we simulated five patients to be added here. So we'll call the register patient service and it will add the patients. Okay. Now after that, now the patient will search for a particular specialization and the strategy that is has been declared above. So it will get the doctor slot list, right? So we can see for this particular slot, Dr. Alice is available at these time slots, right? So the ranking was on the basis of rating based, I think. So since the rating doctor is same, so we can say uh, start time, let's say start. Okay, let's replay this. So you can see this is in ascending order 9:30 in this, right? So let's say if I make this doctor as also as a cardiologist and then I use rating based strategy, right? So then this Dr. Alice should come first, right? Correct. So then the Dr. Alice is coming first, right? And then the doctor, another doctor is coming there, right? Okay. Now this you got the list of all the doctors and the time slot at which they are um available. So if you see here, rating find by doctor specializations and all, right? Or let's say if it does not show if it is available or not. So let me add this. You can get that data later also. Cool. Now let's simulate the next thing. The next thing is the booking of this booking a doctor, right? So what we'll do is we'll pick up the patient one and then book the doctor one at 9 o'clock, right? So then what does it say? It says booking confirmed, B1, and then for the patient is for doctor at 9 o'clock, right? Now, okay, yeah, booking confirmed here. Now what is there? The doctor is wants to see all his bookings. So Dr. Aliska, he can see all the bookings that are there. There is only one booking as of now. Now, what we are trying to do is we're trying to book another slot here, right? So at the same point for the same doctor, doctor one, if you say. So what does it say? Slot not available. Patient is as added to the wish list for 9 o'clock. Booking confirmed null since there is no booking, right? If you go inside this method, we are returning null here. If uh, the booking was not done, right? You can handle all those things. And then what we are trying to do is we're trying to cancel the booking one by the patient one, and then we are trying to see the view the final booking, right? So it should show the patient took a booking. Cool. So if you see, we have canceled the booking, assigning slot to the next patient 1B51. So this is the next patient, right? P2. and then booking confirmed from this patient at 9 o'clock. Booking details, he can see 1B F12, so the same patient it is there for this particular doctor at the time slot, right? Okay, so coming back, I'll just give a glance. So we are using concurrent maps to avoid concurrency issues, and when we are booking services, we are using time basis at uh, time lock, right? Time slot lock, so that another patient does not uh, if another patient is trying to book at the same time slot, then the concurrency is handled, right, using the time slot lock, which is declared in the um, doctor entity itself, right? And this is done at both the times when we are doing the booking and we are doing the cancellation, right? Okay, and then there's a strategy pattern which we have used here, and which is a runtime pattern, which yes, I hope, and you can read this file, uh, how it is working and all the things, what is model, repository, strategies, right? Few examples are also there, also written here, right? Cool. I hope that was it. I've also written this thing, um, concurrency test, uh, right? So when multiple uh, patients are trying to book the same slot, so you can see here there's one doctor which we have booked. There are 20 threads or 20 patients that we are trying to register, that we have registered here, right? And then we have started an executed service, which will run, and it will try to book the slot at this time of point, this time, right? So if you see for the patient one, the slot was booked for this patient at 9 o'clock, and then we are getting not available, not available for the other threads that are there, correct? And yeah, I think, yeah, that's it from my side. uh Please like, share, and subscribe, and if you have any questions or doubts or anything to suggest, please post in comments and I'll take it from there. Thank you so much.